It's kind of funny. You hit send on an email, you click a link, and it just works. But have you ever really wondered what physically happens in that first split second? In this explainer, we're going to trace that exact journey, starting right from your device. We're talking about the network edge. And trust me, this isn't just cool trivia. It's a core concept you are definitely going to see on your computer science exams. So here's our game plan. We'll start right where you are, with your device at the network edge. Then we're going to look at the on-ramps, the access networks that get you onto the internet's superhighway. After that, we'll dive into a critical showdown, dedicated versus shared connections. This is a big one, so pay close attention. And finally, we'll get down to the physical stuff, the actual wires and airwaves that carry your data. All right, let's get right into it. Section 1. Welcome to the network edge. Before we can even think about the massive global internet, we have to start small. We have to start right here, with the device you're probably holding right now. Seriously, think about it for a second. That tap, that click, it's not magic. An actual physical process kicks into gear the instant you do it. So what is that process? Well, that's exactly what we're going to break down. Okay, first things first, we need to get some of the lingo straight. In networking, we call any device connected to the internet an end system, or more simply, a host. And this isn't just your laptop or your phone, the clients. It also means those giant, powerful servers humming away in data centers, serving up all your apps and websites. So all of these devices, from the phone in your pocket to a Netflix server thousands of miles away, they all live at what we call the network edge. They are the ultimate starting and ending points for every single packet of data that zips across the internet. Okay, so we've got all our devices sitting there at the edge. The big question is, how do they talk to each other? How do they connect to the rest of the world? That brings us to our next topic, access networks. These are the absolute crucial links that connect the edge to the internet's core. To put it simply, the access network is your personal on-ramp to the internet highway. It's the physical connection that takes data from your end system and hands it off to the very first router, the edge router, which then shoots it out into the vast interconnected network. For most of us, this on-ramp is our home internet connection, and the technologies that make it happen are probably familiar. You've got DSL, cable internet, and the one everybody wants these days, fiber to the home. We'll also touch on Ethernet and Wi-Fi, which you find pretty much everywhere. Okay, you're going to want to listen up for this next part because it is absolutely 100% crucial for your exams. The difference between how something like DSL and cable internet works is a classic networking question, and it all boils down to one simple idea. Is your connection dedicated or is it shared? Let's look at the blueprint here. DSL, it's the one that uses your plain old telephone line. The key thing is, it creates a direct, one-to-one connection from your house straight to the phone company's office. Now, cable is totally different. It uses the cable TV lines, where all the houses in a neighborhood are basically looped together on one shared wire that runs back to the cable company. And here's why that is so important. With DSL, because you have a dedicated line, that bandwidth is all yours. No one else is using it, so your speed is going to be pretty consistent. With cable, you're on a shared medium. It's like a party line for the whole neighborhood. If everyone decides to stream a 4K movie at 7 p.m. on a Friday, well, that shared pipe gets crowded and everyone's speed can drop. This distinction, dedicated versus shared, is the #1 takeaway here. So, we've made it onto the on-ramp, but what is that on-ramp actually made of? Let's zoom in and look at the physical wired paths that our data travels on. In networking, we call this guided media. Guided media is, well, it's exactly what it sounds like. The signal, whether it's electricity or a beam of light, is physically guided along a solid path. For our purposes, the two most important types are the classic copper wire and the super fast fiber optic cable. And this comparison is another absolute gem for your exams. Copper wires, which are used in DSL and Ethernet, work by sending electrical pulses. They get the job done, but they can be affected by electrical noise from other sources. Fiber optics, on the other hand, send pulses of light. This makes them ridiculously fast and, here's the killer feature, completely immune to electromagnetic interference. That immunity is a massive deal and a huge reason why fiber forms the backbone of the internet today. Of course, not all connections are nice and tidy inside a wire. So for our last section, let's talk about what happens when our data literally takes flight through what we call unguided media. So, with unguided media, the signals aren't contained in a cable at all. They just propagate freely through the air or even through space. This is the world of wireless, right?
Wi-Fi, your cell phone's 5G connection. It's all data being carried over radio channels. But here's the trade-off, and it's a big one. Wireless is incredibly convenient, but it's also kinda fickle. Ever had your Wi-Fi just die when you walk into another room? That's your signal getting blocked, shadow fading. Or noticed your connection is terrible in a crowded cafe? That's interference from all the other signals bouncing around. These are real-world physics problems that a simple, boring old Ethernet cable just doesn't have to worry about.
And all of this leads to a huge final question for the future. As we connect billions, maybe trillions more devices, from smart cars to smart toasters, what is our world going to be built on? Is it going to be the rock-solid, predictable speed of fiber optics buried in the ground, or the go-anywhere, connect-anything freedom of wireless? That's the fundamental tug-of-war happening right now, right at the network edge. Thanks for tuning in.